Why care about a launch countdown now? Because NASA has now shown, in unusual detail, how Artemis I gets from a rocket on the pad to a crewed launch attempt. This is the first crewed mission in the Artemis program, with Reed Wiseman, Victor Glover, Christina Koch, and CSA astronaut Jeremy Hansen set to fly around the moon. The countdown starts about 2 days before liftoff, and it is not just a clock ticking down. It is a structured test of whether the vehicle, the crew, and the ground systems are all ready at the same time. The document also reveals where an ASA builds in time to stop, review, and decide. That matters because modern launches are not decided by one dramatic final moment. They are decided by many smaller moments, each with a clear technical purpose. One useful detail in NAS as releases the difference between L- and T-. L- is simply how far launches from the present in hours and minutes. T- is different. It is the sequence of planned events inside the countdown. That distinction matters because the clock does not always move the same way. NASA includes built-in holds, where the T clock stops on purpose, while the L clock keeps moving toward the launch window. In other words, the countdown is not a straight line. It is a managed sequence with room for decisions. That helps the team hit a precise launch opportunity without losing the entire attempt over smaller timing issues. It also tells us something about launch culture at NASA. Precision is not only about speed. It is about creating controlled pauses so teams can review data, complete procedures, and still protect the overall schedule. Much of the countdown is about turning separate systems into one launch-ready stack. Early milestones include powering up Orion, the core stage, and the interim cryogenic propulsion stage, or ICPS. Then come long preparations for liquid oxygen and liquid hydrogen systems. Later, NASA charges Orion flight batteries and core stage batteries, clears non-essential personnel from the pad, activates the ground launch sequencer, and prepares for tanking. These steps can sound routine, but they show the real shape of the mission. Artemis I is not just about astronauts boarding a spacecraft. It is also about cryogenic propellants, electrical power, communication links, and the choreography between the vehicle and the ground. The countdown published by NASA makes that visible. Before the crew ever arrives at the pad, most of the work is already a careful process of powering, cooling, filling, checking, and verifying systems that all have to behave correctly together. The tone of the countdown changes once the crew phase begins. NASA's schedule shows the close-yet crew going to the White Room, then the flight crew deploying to the pad and boarding Orion about 4 hours before launch. After that come hatch preparations, hatch closure, seal checks, service panel closures, and closure of the launch abort system hatch for flight. By this point, the mission is no longer mainly about vehicle setup. It is about locking the crew into the spacecraft while preserving options if anything looks wrong. NASA also schedules weather briefings, imagery reviews, and final team polls. This is where the countdown becomes easiest to understand as a decision system. Every major action knows the path forward. At the same time, NASA is checking whether it still has enough confidence, enough launch window, and enough margin to proceed safely with people on board. The last minutes are where NAS's release becomes especially revealing. At T10 minutes, the ground launch sequencer initiates terminal count. Then come a tightly ordered series of actions. The crew access arm retracts, Tanks are pressurized. Orion shifts to internal power. The launch abort system becomes available. The flight termination system is armed. Auxiliary power starts. Replenish flows are terminated. And finally, the automated launch sequencer takes over. NASA also explains the rules for stopping the count. Teams can hold at 6 minutes for much of the launch window. Some shorter holds later in the sequence are allowed. But after automated launch control begins, a problem usually ends that day's attempt. That tells us the real tension in the Artemis II countdown. It is not drama for its own sake. It is about how long humans can keep options open before the machine-driven final sequence closes them.